Afternoon. Am I audible? Yes, yes, okay. So, good evening, participants. I am Daniel L. Miguel, returning to help you review for the Mathematics 21. Wait lang. Good afternoon. I am Daniel L. Miguel. Tayo ngayon ay mag-aaral ng concepts about Mathematics 21 for your long exam 2. So, reminders. Here are some reminders to maximize your experience in today's review. Prepare your note-taking materials or applications. We tend to forget things easily. Ay, wait lang, choppy ba ako? Please thumbs up kapag narinig nyo ng maayos yung aking boses. Kasi baka sa akin pala yung issue. Wait lang, I will just check something. Okay, all right. Here are some reminders to maximize your experience in today's review. Prepare your note-taking materials or applications. We tend to forget things easily, so we recommend writing down notes from the review. Please keep your cameras and microphones off for the duration of the review. If you have questions during the discussion, you could put your questions in the chat box. You could also send a private message through the Zoom chat box to Jordan Cadelinia. This review will be live streamed to the MBAN 1 online YouTube channel for educational purposes. You may go back to the recording after the review. This will be a 2-day review. However, you can still view the recording at the MBAN 1 online YouTube channel if you will not be available in one of those days. Okay, so we have the first problem. Problem 1, find all the absolute extrema points if there are any of the function f of x equals inverse of sine x when x for x from -1 to 1, -1 included and 1 excluded, and ln of x plus pi half when x is greater than when ln of x plus pi half when x is greater than or equal to 1. So let's proceed in answering this problem. But first, recall the extreme value theorem. Note that EVT, for the short form for the extreme value theorem, is only applicable on closed and bounded intervals AB for some AB in the set of real numbers. If f is continuous on closed interval AB, then f has both an then function f has both an absolute maximum and absolute minimum on the closed interval AB. So also recall that for open intervals, EVT cannot be applied or uh, basta hindi siya close on both sides of the interval AB. Halimbawa, yung isa dito ay open, isa lang dyan, or para silang open, EVT cannot be applied. For open intervals, find the critical points of the function in the given interval I. So next, for open and bounded intervals, check first if it is continuous on the given interval. Check how many critical points are there. If there is only one critical point, check whether it is a relative extremum or not. If it is one, then it is an absolute extremum, depending if it is the maximum or minimum. If there are more than one, compare the values of x at the critical points to the value of f at the endpoints, or find the limits if it is an open-bounded endpoint. And let's proceed ulit sa isa pang recall. Paano pag intervals with infinite limits or limits at infinity? Check first if the function is continuous on the intervals. Check if the limits as x approaches both infinities is also infinity. If yes, check if they have the same sign. If not, try to find what value the limit approaches to and compare it with the values that the critical points and bounded endpoints give. Or find the limit if it is an open bounded endpoint. Same rule applies for similar intervals. For limits at infinity equal to infinity, there is an absolute extremum if both infinities have the same sign and none if otherwise. If the sign of infinity is positive, then f has no absolute maximum and has an absolute minimum. If the sign of infinity is negative, then f has no absolute minimum and has an absolute maximum. So to summarize, first, check if f is continuous on the given interval. Check the types of bounds if it is a closed or open interval. If it is closed, use extreme value theorem, or if it is open, try to use the other methods earlier mentioned. So to find the continuity of the piecewise function f of x, let us first evaluate, analyze if these two pieces of the piecewise function is continuous within their own domains. So the inverse sign of x is continuous on the interval -1 to 1, 1 included, 1 excluded, since the domain of inverse sign of x is the closed interval -1 to 1. And also, ln of x plus pi half is continuous on the interval 1 to infinity, 1 included, since the domain of ln of x is from 0 to infinity, 0 not included. Now, let us check the continuity at x equals 1, since as we can see, there may or may not be a discontinuity when x equals 1, because as you can see, dito sa ating piecewise function, nagbabago yung condition natin pag yung x natin ay 1. So recall that in order to prove that a function is continuous at at some x equals some value a, I'll check if f of a is defined, and if it is equal to the left hand and right hand limit of the function. So f of 1 is we will evaluate it at ln of x plus pi half, since it is included in the interval x is greater than or equal to 1. Okay. So f of 1 equals ln of 1 plus pi half. Ln of 1 is 0. So our f of 1 is pi half. And now we will evaluate the limit of f of x as x approaches 1. So when inverse when the limit for the left hand limit of the function, we have limit of arc of inverse sine of x as x approaches 1 from the left is equal to pi half. So kayo na bahala ba't naging pi over 2 yung as arc sine of 1. Well, kung titingnan nyo lang yung unit circle, alin doon yung alin sa domain ni sine, ni inverse sine of x, yung value ng x, or alin doon sa unit circle, anong angle from anong angle doon yung mag-give ng value na 1. Pag nag-sign of nag-sign of angle ka, magiging 1 siya. So ang pagiging sagot doon ay pi half. So ayun. So dito naman sa right hand limit, ln of x plus pi half, tapos i-evaluate natin siya as x approaches 1 from the right. So ang mangyari dyan, ln of 1 is 0, then 0 plus pi over 2 is pi over 2. So since ito ay pi over 2 at ito pi over 2 din, tapos equal siya sa value ng f of 1, continuous na at x equals 1. Recall na sa paghahanap natin ng critical numbers, hahanapin natin una yung derivative ng f of x. So ang derivative ng f of x ay 1 over square root of 1 minus x squared when x is between -1 and 1, open interval siya, or 1 over x if x is greater than 1. So, ayun, recall na lang kung ano yung bakit naging, ayun ang bahala mag-recall kung paano naging ganyan yung derivative ni inverse sine of x at ln of x plus pi over 2. So kukunin natin yung muna yung limit ng f prime of x as x approaches 1. So kung makikita natin at f of prime, the limit of f prime of x as x approaches 1 from the left, magiging infinity siya. Kasi yung dito papasok yung 1 from the left, ito siya dito siya magfo-fall. So ito yung gagamitin natin. So 1 over 1 minus 1 from the left. So magiging 1 over 0 from the left siya. So magiging magiging naka-square pala siya. So yung 1 from the left natin, 1 from the right, or wait lang, i-ano ko lang sa saglit. Ayan. So meron tayong limit of f prime of x as wait lang, x approaches 1 from the right. So pag ganan, isa-substitute natin dito yung -1. Erase ko lang to saglit. Lalagay na natin itong ano. So, isa-substitute natin 1 over 1 square root of 1 minus the square of 1 from the left. So, mangyayari dyan, 1 from the left, magiging 1 from the right siya. So parang nag-apply dito yung loss of multiplication of negative integers, or basta negative, basta yung pag negative 1 times negative 1 ay 1. So dito naman, pag 1 from the left times 1 from the left, 1 from the right siya. So magiging 1 over 1 minus 1 from the right. So ang susunod na mangyayari naman, magiging 1 over 0 from the right siya. So kaya naging positive infinity siya. So erase ko lang ito saglit. Tapos, pag naman i-evaluate natin yung limit as of f prime of x as x approaches 1 from the right, magiging 1 naman siya. So therefore, f prime of 1 does not exist. Kasi yung isa, yung left hand limit ay equal sa positive infinity, yung right hand naman ay equals to 1. So, ang conclusion dito ay walang values ng x na that will make the sub-functions 0 or undefined in their respective intervals. Therefore, the only critical number on -1 to infinity is x equals 1. So, ayun. So, tatandaan nyo lang na ito wala siyang value ng x na maging 0 to. Same here. Ganun din. So, ang magiging lang natin, ang magiging critical number lang natin ay x equal to 1. X equal to 1 kasi ginagawa niyang nagkakaroon kasi doon ng discontinuity sa f prime of x, kaya yun yung maging critical number natin. So next, ayan. So next, we use STP. So una, hanapin natin yung f double prime of x. Tapos, yung f double prime of x equals x all over the square root of the cube of the of 1 minus x squared when x is between -1 and 1, an open interval, or -1 over x squared when x is greater than 1. So again, recall kung paano nakuha to. Ayun, so using the rule for deriving the f of x over d of x. Kasi ito naman ay power rule. So yun, remind lang na kailangan alam niyo pa rin itong mga concept na to. So, ngayon naman, meron tayong kakaroon tayo ng parang table dito. So, x equals 1, Tapos, x is between, uh, x is between 1 and 1, open interval, tapos yung huli naman 1 to infinity. So, yung f double prime of natin, ano yung magiging sign niya when x is between -1 and 1. So, kunin natin yung 0. So, 0 over 1 minus 0. Ayun, so ayun, may ano pala reminder lang. So, kasama din pala sa critical points, um, yung f double prime of x, na where x is, f double prime of x na where it will become 0, yung x ay magiging critical point natin. So, at 0, at x equals 0, yung f double prime of x natin ay 0 din. So, ayun, let me just add this. 0, 1, tapos meron tayong 0 dito, x equals 0. Tapos, -1, 0. So, ang nangyari dito, so i-recall din na yung f double prime of x natin equals 0, yung x na yun yung possible point of inflection. So, at from the interval, open interval -1, 0, ano yung maging characteristic ng ano natin, f double prime of x. So, evaluate natin, halimbawa -1/2, so yung -1/2 over 1 over the square root of the cube of 1 minus the square of -1/2. So, ayan. Pasensya na medyo magulo yung ano ko. So, magiging to 1/4. So, 3/4. Ang cube ng 3/4 ay positive. So, negative divided by positive ay negative. Kasi ito 0. Tapos, 1. So, 1/2 naman gamitin ulit natin dito. So, magiging positive na to. So, positive divided by positive. So, positive pa din. Tapos, at x equals 1, ano ba yung x equals 1? Undefined siya. Tapos, 1 to infinity naman, open interval 1 to infinity. At ano naman yung characteristics? So, gamit tayo na, ano bang madali dito? Ayan, 2. Gamitin natin 2. So, 2, eraser lang ako saglit. So, 2 over 1 minus 2 squared. 1 minus 2 squared, tapos i-compute natin siya. So, 1 minus 4, so -3 yung cube niya, so -2. Yan. So, evidently, ayun. So, ang mako-conclude natin dito ay dito. Let me just check dito sa unang interval. So, yan. So, ulit, -1/2 over 1 minus wait lang. Please excuse me, meron lang tumatawag sa Ayun. So, pasensya na sa ano, sa abala. So, negative 1/2 over ah, okay, so negative 1/2 over ah yan. So, 1 - 1/4, so 3/4 ayun. So, kasi ang mangyari dito kasi sa graph, ah kung alam niyo yung itsura ng kung alam niyo yung itsura ng ay if is x equals 0 a critical number, ano, i-recall lang natin na ano na possible point of inflection ang isang x value kung nagiging 0 yung f double prime of x. So, halimbawa ano, dito kasi ano siya 'di ba, pag i-substitute natin yung 0 dito, so 0/1 - 0, so magiging 0 siya. So therefore, possible point of inflection siya kaya sinama ko siya dito sa ano sa table. So kung tatandaan, kung alam niyo yung graph ng inverse of sine x, ganyan yung itsura niya, 'di ba? Tapos yung graph naman ni ln of x plus pi over 2, magmumula siya, mangyari diyan mula dito, magiging ito 'di ba ang range kasi ng ano ng inverse sine of x natin from negative pi over 2 to pi over 2. So ito dito magmumula yung second sa function natin, tas mula diyan ano yung graph ng ln of x plus pi over 2, pag gano'n naman siya. So ayan. So kung mapapansin ninyo, ito yung x equals 0, tas ito naman yung x equals 1. So kung mapapansin ninyo dito, parang nagkaroon tayo ng what do you call it, a cusp dito. Parang tapos dito naman nagkaroon kayo ng point of inflection, because na sa point of inflection nagbabago bigla yung yung direksyon ng inyong graph. So dito concave down siya, dito concave up. Ganun. So yun lang, yun yung conclusion natin. To the left of x, so yun yung conclusion natin, concave down siya. Dito sa interval na to, concave up siya. Wait lang. Concave up siya. Tapos, dito naman sa 1 to infinity, concave, ano siya ulit, concave up. Wait lang. Ano din siya, concave down. Kasi yun nga, negative yung nakuha natin kanina. So, ayun, elaboration lang dun kanina sa ano natin. Ay, wait lang. Hindi, ano pala, mali pala tong sketch. So, ganito pala siya dapat. Yan. Correct lang, correct me if I'm wrong lang ha. Hello po kuya, tanong ko lang po sa interval ng 1 infinity, di po ba siya undefined? Kasi po pag sinubstitute po sa lahat ng numbers sa loob ng square root, magiging negative po. Wait lang. Okay, so okay, wait lang ha. Evaluate ulit natin ha. So 2, tingnan natin ha, 2 Ay, ano, wait lang ha, let me just repeat. Hindi po, hindi po ba, hindi, wait lang, mamaya pala natin to i-entertain. Meron pa kasing mga kasunod na ano to, na part. Erase ko lang to. Ayan. So, check the endpoints of the interval. So, ang endpoints natin kanina ay yung nakuha natin -1 at positive infinity. So, at positive infinity, ah yung ano natin, limit natin ay infinity din. So, ang conclusion natin ay walang absolute maximum. So, yun lang. Recall lang na ano, kapag yung na kapag ang yung kapag meron kang ano infinity ay ayun, maaaring meron kang absolute walang absolute maximum or walang absolute minimum. Tapos naman sa f of -1, ang magiging ano siya inverse sign of -1. So maging -5/2 siya. So dahil walang ibang critical points na since there are no critical points that came out as a relative minimum, the absolute minimum point is at -1, -5/2. So it's tapos and also there are no absolute maximum points and the absolute minimum point is at -1, -5/2. George, pwede na ba, sasagot na ba ako ng questions?
Okay, yes. So, bale, actually, yung ibang questions dito, I'll answer this na lang at the end of the session. May isang nagpa-clarify sa akin. Parang imaginary yata ang interval na 1 infinity. Just to ask, paano interval? Sa f of x or sa f double prime of x? So double prime. Okay. Okay. I can actually answer this. So, bale, as you notice, yan, sige. So, bale, sa f double prime of x, mapapansin nyo na -1/x² siya if x is greater than 1. So, at that point, yung drawing niya is actually like this. Mag-ano lang saglit. So, bale, from 1 to positive infinity, ang drawing niya is actually like this. Concave down siya. Since magiging ano lang to, negative naman siya regardless kung anong value niya. So, hindi siya magiging not really imaginary. Pero it just means na concave down yung portion na to at pag in-evaluate. Yun lang.
So yeah, ano lang, to add lang ha. So ito yung nakuha natin kaninang ano, so graph. Kung ika-graph natin yung function, bale ganyan yung itsura niya. So ito yung graph for ayan. So ito lang yung from -1 to 1. So including yung -1 pero excluding yung 1. So ito yung graph niya. Tapos nag-limit sila at this some y equals pi/2 plus x equals 1. Tapos kung mapapansin niyo, ayan, yan yung ano niya. Yung ln of x. Kasi kapag yung tandaan nyo na pag ganito yung exponential pero yung graph ng exponential pag ganan, pero yung logarithmic ay pag ganun naman. So ayun. So kaya naging concave down yung nakuha natin sa interval na open interval na 1 to infinity. So yun lang, additional info lang. So, okay.
May questions ba
Ayan.
sa part mo, DM?
Doon po pala sa x equals 1, infinite discontinuity dapat. Wait, anong ano yun? Anong part? An yung nagsagot, yung nag-ask nitong question, anong f prime of x, f of x, or f double prime? Wait lang. At x equal 1, hindi siya, pero sa continuity check, hindi siya lumabas na infinite discontinuity kasi, ayun, ano lang, continuous siya as it turns out. Pero kanina, kaya kung titingnan natin sa f prime of 1, hindi siya nag-exist yung hindi siya nag-exist dahil recall that uh, that kapag meron kang cusp, kasi i-drawing ko ulit yung pag may cusp ka, ito parang dito siya, parang may sudden na nagbago. So, cusp yan. So, therefore, hindi nag-exist yung derivative, yung f prime of 1. So, kaya, ayun, hindi siya nag-exist. So, at same thing din sa sa f double prime of x, suddenly, wait lang So, wait lang, tingnan natin f double prime of x. Ayun lang, so dun din hindi rin defined yung f double prime of 1 consequently. So yun. Next question. Ayun, wala nang question. So kung meron pa kayong additional questions after na lang ng session after na lang i-discuss yung mga susunod na problem namin sa i-entertain. So yun lang. Okay. Next part.
Wait lang. Before mag-proceed sa next problem, just a general reminder po na sa akin po questions, PM nyo po sa akin, hindi po kay DM. Thank you.
Okay, so problem 2. Consider two protons on the x-axis. One is at the origin and the other at 1, 0. Find the coordinate at the point on the line x equal to where the electric field magnitude is at maximum. The electric field magnitude is given by capital E equals K times small e times the quantity 1 over the square of r sub 1 plus 1 over the square of r sub 2, where k small e is greater than 0 and r sub 1 and r sub 2 are the distances from the first and second proton respectively to the point. Okay, next. So recall that in solving optimization problems, first, draw a diagram of the problem corresponding to a general solution. Assign variables to all quantities so involved. Identify the quantity, say some quantity Q, to be maximized or minimized. Then write a formula for the function that is to be maximized or minimized. Use the given constraint to express the formula from step 4 in terms of a single variable. Determine the domain or constraint of quantity Q from the physical restrictions of the problem. Use appropriate theorems involving absolute extrema to solve the problem and make sure to include the units in your final answer. So, ayun. Ito yung solution. First, magdodrawing tayo ng diagram. Meron tayong some proton at the origin and other at 1, 0. So, tapos meron tayong line na x equal to na kung saan hahanapin natin dito sa x equal to kung saan magiging maximum ang ano natin, yung E. So ayun. Tapos yung point na to, alam na natin na yung x equal to, pero ang tanong ano yung y. So any point on the line x equals to is of the form 2y where y is in the set of real numbers. To make capital E a maximum, differentiate and either solve for E prime of y is equal to 0 or locate any points where E prime of y is undefined. So r sub 1 equals 4 plus y squared and r sub 2 is equal to 1 plus y squared. So bakit? So ayun lang So yung ano natin, yung kung tatandaan natin, ang formula, parang makakabuo ka dyan kasi ng from 0 to 0 to the x equals to makakabuo ka dyan ng or let's just say na gagamit tayo ng distance formula. So kaya nakuha natin to ayan, itong r sub 1 equals 4 plus y squared. Tapos, ganun din sa r sub 2. So, 1 plus y squared. So, yun, naging ano siya, distance formula. Or, you could also think of r sub 1 and r sub 2 as radius of some circle of some circle. So, pwede din gumamit ng r squared equals x squared plus y squared. Pwede nyo rin gamitin yun. Or the distance formula. Actually, it's just almost the same concept. So, ngayon naman, meron tayong E equals K times small e times the quantity 1 plus, ayan, sinubstitute na natin yung values ng r sub 1 at r sub 2. So, 4 plus y squared 4 plus y squared plus 1 over 1 plus y squared. So meron tayong E prime of y equals k times small e times the quantity negative 2y over the square of 4 plus y squared plus negative 2y over the square of 1 plus y squared. So we know that E prime of y is always defined since the denominators are never zero. Kasi, tawag dito, so mangyari kasi dito, ayun, so for E prime of y equals 0. So 0 equals small k times small letter E multiplied to this quantity. So ano lang natin, fa-factor out natin si negative 2y. So note that k is greater than 0 and small is greater than 0 by assumption. If it is always the case that this quantity is always greater than 0 since both denominators and numerators are always positive. Therefore, we must have y equals 0 as the only critical number. So the question now is y equals 0 a maximum or a minimum? Let's examine the vicinity of y equals 0 using the first derivative theorem. First derivative test, choose 2 points, y close to 0. So E prime of y equals k times E times the quantity -2 over 5 squared minus -2 over 1 squared. So magiging -2 over 25 minus -2 over 1. So pag pinag-minus mo sila, mag-negative 29 KE over 50, which is less than 0, which means that that any point, any value of y less than 0, E prime of y is decreasing. And similarly, when E prime of -1 it is equal to 29 KE over 50, which is greater than 0, which is increasing. So hence, so yun, kaya tayo nag-assume na ayun, na positive tong si K at saka si E para malaman natin kung ano yung magiging behavior ng value na to, kung ano man ang y value natin. So therefore, there is a local maximum at y equals 0. Since there are no other critical points, the function must decrease indefinitely going to the right and increase indefinitely from the left. The maximum is at y equals 0. Capital E is maximum at the point 3, 0. So, ayun. So, kaya siya naging 3, 0 dahil, ayun, balikan lang natin dito. So, magiging, siya, 1/4. So, yun lang. So, any questions?
Hello, I'm back. So, bale, I almost forgot na may nakaligtaan tayong tanong. Hello po, do we need to use both FDT and SDT in open interval problems? Ako na siguro magsasagot nito. Actually, hindi naman. FDT and SDT naman test for relative extremas and you can just only use one of them para ma-solve. Then the other questions, actually, I'll answer this na lang mamaya sa end of the meet. So, ano po ulit yung FDT?
First derivative test. Yung pag-kukulit ko yung first derivative ng given function, tapos you're going to determine the behavior of the graph using the first derivative test. So, ayun, titignan mo kung alin-alin yung mga values. Halimbawa, meron kang f of x, f prime of x. Hanapin mo kung ano yung mga x na magiging 0 si f prime of x. Tapos, those values of x will partition the domain into several intervals, and then you will determine what is the characteristic of the graph within those intervals. So it could be increasing, decreasing, or something else. Yun. So you need to recall some some concepts from the previous lessons. May isa pang nagtanong, please be reminded na kay Jordan Cadelinya kayo mag-PBM ng inyong question. So, paano po nakuha yung R sub 1 at R sub 2? So, recall that R sub 1 and R sub 2 are the distances from the line x equals 2. So yun, ayan, it's also, ayun lang. So it's either by distance formula or by ayun lang, formula of a circle, makukuha ninyo yung value ni r sub 1 at r sub 3 in terms of y kasi meron na tayong x. So yun lang.
Okay. So, bale may question from the audience. Sir, paano po ulit nakuha si negative 29k over 50? I think this is pertaining to yung e prime of 1.
Okay. Okay, ito, ano lang, negative 2 over 25 minus negative 2. So, wait lang. Palit lang ako ng ano. Wait lang. Balik tayo dito sa e prime of y. So, yun. So, di ba at 1, i-evaluate natin at 1, so magiging ito 1, kasi ito magiging 1. Magiging ano sa, wait lang, iyan natin. Ayun, wait lang. Dito, hindi pala ito yung original ano, equation. So yun, meron tayong ito yun. So at 1, wait lang. Negative 1 ba yun? Ayun. So magiging ano to, 2 times 1, so magiging negative 2 over 5 squared. Tapos ito naman, negative 2 plus negative 2 over 1 plus 1, which is 2, squared, which is 4. So 25 over 4, which is magiging 1/2 siya. Tapos magiging, ano siya, magiging 25 over 50, wait lang negative 25 over 50, tapos ito naman magiging, so negative 4 over 50. So kaya siya naging negative 29 over 50. Ayun. Wait lang. Bale, may typo error pala dito sa isang to. Dapat 4 yan. Yan. So, any other questions?
Yes, meron pa. Sa SDT naman po, ano po ulit yung chine-check?
SDT, bale sa SDT, ang chine-check doon, wait lang. Ang ibig mong sabihin ba, ano yung gamit ng SDT sa optimization problem?
Yes.
Wait lang. Kasi ang optimization problems, ito yan. So, bali, ang nangyari kasi dyan, you could use SDT to determine what would be the possible point of inflection where the graph suddenly changes in its concavity. So, depende rin sa problem yun, no? Pero yun lang. Dito kasi parang naging FTT yung natin. So dito, Teka. Teka lang, inom lang ako tubig.
Okay, siguro let me explain siguro a bit tungkol dito sa SDT. So as I mentioned kanina, SDT is actually using the second derivative to check kung relative maxima or minima ang makukuha mo sa problem. So kunwari, may critical points ka, let's say let's say 1 yung critical point mo. Bale, ang second derivative test checks kung anong klaseng critical point yung 1. So if greater than 0, automatic ano na siya, yung f double prime of 1 greater than 0 kunwari, that means na yan yung relative minimum. Tapos if I remember correctly, f double prime of 1 is less than 0. That means na siya yung relative maximum. So ganun usually yung ginagawa sa SBT. So okay ba sa nagtanong? Okay, ayun. So may isa pang question dito. Kung distance formula, hindi po ba dapat R1 equals square root of 4 plus y squared and R2 equals square root of 1 plus y squared? Sige. Wait lang. Actually, may typo dito. Yes, actually tama ka. Dapat may square root to. Medyo may typo lang ng onte. Pero either way, pag sinubstitute naman dito sa e of y, magiging ano naman yan, r1 squared naman siya. So, you don't need to worry about the interval. Tapos meron din, paano po nakuha yung 3-0? Hindi daw ba dapat 2-0 kasi 2y naman yung hinahanap ng maximum? DM, are you there?
Wait, at paano yun nakuha yung 3-0? Ba't hindi, o nga no? Wait lang.
Baka daw typo. Hindi, yeah.
Yeah, yun nga, na-type po tayo. So, ayun lang. Parang yung y ko 0 na yung nahanap nating value ng y na magiging maximize yung ano natin, yung e of y natin. So, yun. May iba pa bang questions? Nasagot ba yung question?
Yeah, mukhang nasagot naman. So, wala nang ibang questions dito sa akin.
So, okay. So, thank you thank you thank you to the participants. Again, I am Daniel L. Miguel, and we will have a short break.
Okay, so welcome back. Thank you for having this short break. So now we'll proceed with problems 3 to 6. So again, if you have any questions, just private message me and I'll entertain them every end of the questions. And for some general questions, I'll be answering them by the end of this session. Okay, with that, let's proceed with problem number 3. So problem number 3, Will, situated at the origin, sees a cockroach 13 meters north from him. The cockroach begins to crawl south at a pace of 1 meter per second. Will, who is very afraid of cockroaches, starts running at a speed of 1.5 meters per second. After 8 seconds, what is the instantaneous rate of change between Will and the cockroach? So I almost forgot to mention that Will is running in the direction of the positive x-axis. So to solve this, we need to recall some concepts. So we are going to recall 3 concepts for this problem. So the first one is rate of change. So usually, rate of change is represented by the slope of the curve y equals f of x. In other words, the average rate of change in the interval x0 to x is given as the slope. So bale, ang form niya palagi is itong f of x minus f of x0 all over x minus x0, or simply change ng f over yung change ng x. So annotate ko ng saglit, how do we visualize this? So bale, kunwari meron kang isang curve dito, then let's say this is x0, tapos let's say this is x. So bale, kukunin lang natin yung slope nitong curve na to. So this is x0, then this is x. Then of course, yung values lang naman is fx0 tapos f of x. So kinuha lang talaga natin yung slope ng curve na nagko-connect sa dalawa. So we usually call this a secant curve. Then this shows how y changes, how fast y is changing with respect to x. Okay, so let's proceed next. So for instantaneous rate of change, for one to find the rate of change of a function at the instant where x equals x0, take note, ang keyword natin dito ay instant. It is sufficient to find the derivative of x evaluated at x equals x0. So in other words, we are just finding the so ito, yung kaliwa, this is just the definition of the limit. Usually hindi naman to lumalabas. So limit as x approaches x0 ng difference ng fx at f of x0 all over x minus x0, which is also ito. Then which is also equal to yung derivative ng f evaluated at x. So next, andito na naman tayo sa mga remarks tungkol sa derivatives. So let y equals f of x. Then may tatlo tayong conditions. If yung change is greater than 0 on an interval I, that means y changes the same way as x changes. Ang ibig ko sabihin dito sa same way is that if x increases, y must also increase. Tapos if x decreases, then y must also decrease. Next naman, kung less than 0 naman ang change sa interval I, y changes the opposite way as x changes. Kung dito sa una, same yung direction ng change, dito naman opposite yung direction. So bale, if x increases, yung y naman natin this time decreases. Tapos if x decreases, yung y naman natin nag-i-increase. Tapos last but not least, kung wala na bang change na nangyayari or dy over dx equals 0, so y does not change when x changes. Okay? So next, let's focus on the second part, which is rectilinear motion. So let s of t be the position function of the particle moving along the x-axis as time t changes. Then meron tayong tatlong important parts dito. The instantaneous velocity of a particle at time t is v of t equals yung derivative ng position function at t. Then the speed of the particle at time t is always the absolute value ng velocity ng particle. Since ang speed naman, it doesn't, wala namang negative na speed. Tapos last but not the least, the instantaneous acceleration of a particle at time t is a of t equals yung first derivative ng velocity, which is also equal to yung second derivative ng position function. So bale, take note ka, we're not finding the velocity, but we're finding yung velocity at saka acceleration at the instant value na t. So, pwede mag-change siya over time, pwede maging constant. So, yun yung tatandaan. So, next, some remarks for velocity function. If v of t is greater than 0, the particle is moving in the same direction as s at time t. Tapos, kung velocity naman natin less than 0, the particle is moving in the opposite direction as s at time t. Tapos, kung v of t is 0, then the particle is not moving or changing direction. So, bale, yung remark tong v of t is just similar lang sa remark ng nauna, which is yung tungkol sa rate of change na dy over dx. It's just that, in-apply lang natin to in terms of the velocity function t, v of t. So meron din tayong remark for acceleration. So if a of t is greater than 0, then the velocity of the particle is increasing at time t. So meron tayong two things to check. So kung greater than 0 ang ating velocity, then yung speed ng particle is increasing at time t. So kunwari isipin mo, parang isang kotse na mabilis na, tapos bumibilis pa lalo kasi nag-change ang acceleration. Then if yung velocity is less than 0, then yung speed of the particle is decreasing at time t. So kunwari meron kang speed ng isang kotse, tapos parang bumabagal siya. Yun yung isipin niya sa slowing down. Ngayon naman, if a of t is less than 0, then the velocity of the particle is, may typo dito, decreasing dapat to at time t. So, bale, if v of t is greater than 0, nagde-decrease yung speed ng particle. So, bale, parang, nagbabawas na yung anyang acceleration. Then, if v of t is less than 0, then the speed of the particle is increasing at time t. So, bale, pag nasa opposite direction na siya, nag-i-increase pa lalo yung kanyang acceleration since parang nagde-decrease yung acceleration. Then, if a of t is equal to 0, then the velocity of the particle is constant. So, take note, important to, it doesn't mean na hindi na siya agad nag-move. So, pwede ang velocity mo is 3 all throughout time. That means na ang constantly moving lang ating particle. Ang only time na not moving siya is kung yung velocity natin is equal to 0. So now, let's proceed to the last part, which is solving related rates. So, bale, related rate problems are actually problems na ina-apply lang natin yung rates of change at saka rectilinear motion. So, here are some tips na that might be helpful in solving this. So list down all the given. If possible, visualize the problem by creating a diagram. So meron tayong diagram mamaya sa problem na to. Then, identify what is required for the problem. So kunwari, meron kang mga given. So let's say, ang given mo is S of t. Tapos kunwari, hahanapin mo is yung V of t. So hanapin mo kung ano yung required sa problem na yun. Next, set up for an equation that describes the relationships of the given and the required. So take note, yung mga equations na binibigay so far are usually relationships ng mga variables. So kunwari, meron kang nakikitang y equals x squared plus x plus 1. Yan yung relationship ng y sa x or y in terms of x. Ganun yung ibig kong sabihin dito sa relationships. Next, try to express the required variables in terms of the given. So, bale, ibig ko lang sabihin dito, we're gonna isolate yung required. And yung required, we need to solve it in terms yung mga given natin. Then use derivatives and the previous recalls kung kailangan to find the rate of change. Then last but not the least, solve to find the answer to the problem. So with that, let's now solve the problem number 3. So, solution. So, we visualize first yung ating diagram. So, as you can see, we will begin at the origin, 0, 0. Andito siya sa baba. While the cockroach is at 13, 0, from 13 meters, 0 meters. Actually, ano pala dapat to? Kasi this is the x at saka y-axis. So 13.0 actually should be 0.13. So sorry, may minor error lang slides dito sa problem. So nasa y-axis siya, so andito siya sa point na to. So at t equals 0, ito yung mga positions nila. So yan yung positions nila. So clear lang natin siya. Okay. So next naman, we try to draw after 8 seconds. So bale, how do we solve for this? This is, baliktad din pala ulit. This should be, wait lang. So, this should be 12.0. Tapos, itong cockroach na to nasa 0.5. So, paano natin na-solve tong part na to? So, take note na based dito sa problem, the cockroach begins to go south at 1 meter per second. So, after 8 seconds, muwaba siya ng 8 meters. So, bali, we just subtracted yung final position niya, which is 5, from 13. So, bali, yung mangyayari is 13 minus 8. Yung ano niya is parang bumaba siya ng 8 meters. Kaya nandito siya sa 5. Then, yung dito sa 12.0, kaya siya ganyan, since 1.5 meter per second, i-multiply mo lang siya sa 8. So, that's 12 meters. Tapos add mo lang dito sa initial position niya sa x-axis. Kaya, ang final position niya is 12.0 at saka itong 0.5. Okay, so with that, so the distance is given by r equals square root of x squared plus y squared. Kasi, whenever we draw the figure, ang lumalabas dito ay isa siyang right triangle. So, bale, when we connect this, take note na isa siyang right triangle. So ganito itsura niya. So, pag nandito siya, bale, ano na siya, straight line. Tapos, parang nag-change over time yung distances nila. So, pag pumunta yung cockroach, pumunta dito sa kanan si Will. So, bale, yung na-form niya, you'll get this eventually pag nasa physics na kayo. This is vector drawing. So, bale, meron tayong cockroach, tapos nag-ano yung distance si Will. So, bale, ang final na distance nila will be this arrow. Then, magpo-form tayo ng isang right angle. Kaya, ang r natin is square root of x squared plus y squared. Okay, with that, so ang relationship ng r sa x squared plus y squared is that ang r squared natin is x squared plus y squared by Pythagorean theorem. So take note na kaya natin ginanito ang form kasi mas madali nating i-differentiate ay implicit differentiation. So this is what we do. We differentiate on both sides with dr with respect to dt. With respect to t. So bale mangyayari is that magiging 2r to times dr over dt equal siya sa 2x times dx over dt. At saka dapat ano pala to? Dapat 2y pala to. 2y dy over dt. So bale, this is just chain rule kasi we are differentiating with respect to t. So bale, we're not only differentiating yung x squared, we're also differentiating x mismo. So after nito, syempre, ibababa yung variable, like dito, 2x, tapos i-multiply mo sa derivative ng x with respect to t. Kaya dx over dt siya. Okay? So next. So we list down the given naman ngayon. So after 8 seconds, yan yung goal natin. Ang x natin is 12, ang y natin is 5. So bali ang r natin is square root of x squared plus y squared equals 13. Then dx over dt is 1.5 since pakanan naman si Will. Then ang dy over dt natin is negative 1. So yan yung parang velocity ng ating mga given, which is si Will at saka yung cockroach. Kaya if you plug in these values, makakuha natin na 2 times 13 times yung rate of change ng r equals 2 times 12 times 1.5 plus 2 times 5 times negative 1. So take note na we are finding yung rate of change at the instant where t equals 8. Kaya na-substitute na agad natin itong parts na to. Kaya ang makukuha natin, this is 24 times 1.5. So bale 36 to. Tapos wait lang, sorry. 24 times 1.5, this is 36. Tapos, 2 times 13 is 26. So, then, 2 times 5 is 10 minus 1 is -10. Kaya ang sum nito is 26. So, if we divide this both sides by 26, makukuha natin na ang dr over dt natin ay 1. So, ibig sabihin, therefore, the instantaneous rate at the instant where t equals 8 seconds is 1 meter per second. Okay, so with that, are there questions from the audience? So, kung wala, let's proceed ngayon to the next question. Okay, so problem 4. So we are to find the local linear approximation of f of x equals x cube root of quantity x plus 1 and use it to estimate the value of 7.02 cube root of 8.02. Express your approximations as a lowest term fraction. So how do we solve this? Let's recall some concepts. So meron tayong ang differential dy and we use this differential dy to find the local linear approximation. So we are given y equals f of x and a small number dx. So isipin nyo itong dx natin is an increment dun sa ating problem. So dx, so kunwari let's say this is x naught, tapos ito yung x. Bale, ang ibig sabihin ng dx natin is itong part na to, yan yung difference nilang dalawa, dx. Or if napansin nyo kanina, this is also equal to itong delta x. Or ibig sabihin lang nito, yung change lang ng x from this point to another. Okay, so next. So we use this fact. So bale, ang dy natin equals f prime of x dx, which is just approximately equal to itong f of x plus dx minus f of x. Take note na ang importante dito yung approximate na value. Then, to find our local linear approximation, letting x be the number near x naught, we have the following. So, ang f of x natin is approximately equal to L of x. Take note yung word ng approximate. This is important kasi we are not really finding the exact value, but rather an approximate value given some conditions. So, ang approximate value L of x is equal to f of x plus f prime of x times x minus x naught. So now, with this, we can solve the problem. So first, we must find f of x ng ating f of x. F prime of x ng ating f of x equals x times x plus 1 raised to 1/3. So bale, to get this, we find the derivative. So mangyayari, product rule lang yan. So derivative lang ng x times yung x plus 1 raised to 1/3 plus yung derivative nitong x plus itong times yung derivative constant x times itong derivative ng x plus 1 raised to 1/3, which is 1/3 times x plus 1 raised to negative 2/3. Tapos ang ginawa lang, sinimplify lang siya. Ginawang common denominator para ma-combine into one single term. Kaya ang nakuha natin na f prime of x is 4x plus 3 over quantity t cube root ng x plus 1 squared. So, to solve f prime of 7, we just substitute lang 7 dito sa f prime. So, ang mangyayari is that f prime of 7 equals 4 times 7, which is 28 plus 3 is 31, plus 3 cube root of 7 plus 1 squared, which is cube root of 8 squared, which is cube root of 64, which is just equal to 4. Or pwede nyo gawin, kunin nyo muna cube root ni 8, which is 2, tas square mo, which will still give us the same answer na 4. So, f prime of 7 is like 31 over 12, kasi 3 times 4 is 12. Tapos, at x naught equals 7, ang L of x natin is 14 plus 31 over 12 times x minus 7. So therefore, ang ating L of 7.02 is equal to, this must be 14 pala. Medyo may typo ulit tayo. So 14 to plus, plus 31 over 12 times 7.02 minus 7. So that's 0.02, which is also equal to 2 over 100. So pag multiply natin dito, magiging 31 over 12 times 2 over 100. Cancel out yung 2 at saka 12, magiging 31 over 6 times 100. Kaya 31 over 600. And we add 14 dito para makuha natin ang 14 and 31 over 600. So, let me check lang kung may questions. I think may dalawang nag-chat. So, okay. X minus X naught. Nalilito po ako sa difference between differential and local linear approximation. Okay. So, back ulit natin. Sige. Wait lang. Ay, sorry. Lagpasan ng konti. Okay. So, bale, for this portion, differential, ano lang yan? So, this is our dy natin. So, which is approximately equal to, which is equal to itong f prime of x dx. So, ibig lang sabihin nun, yan yung difference ng ating y function. So, which is itong f of x, f of x plus dx minus f of x. Notice na ang form nito is always equal to yung slope. So, recall natin from yung previously na ano lang to, f of x. So, bali may ano lang tayo, may yung slope natin kasi is, wait lang. So, recall lang na yung f prime of x natin, which is just the derivative, is yung limit as x approaches 0 ng f of x plus dx plus minus pala f of x all over itong dx. So, bale, take note na this is just equal to yung dy over dx natin. Yung limit as yung ating dx approaches 0, ano pala to? Dy over dx. So, ayan yung parang increment natin dito sa ating, yan yung increment natin ng f of x from x to some other x, gano'n. Yan yung ibig sabihin ng differential na dy. So, kung i-graph natin siya, so let's say this one. So, I'll get this one at saka this one. So, kinukuha ko lang yung distance from itong from this part hanggang dito sa portion na to, which is basically yung height ng ating function. This is equal to dy. So, bale, ang ginagawa lang dito, ayun, hinahanap lang natin yung difference nila. Kaya ganyan yung form. Okay ba sa nagtanong? Then, ang local linear approximation, bale, is basically, parang approximate value lang siya if we evaluate if we evaluate at a certain x. So, di ba, f of x not, kunwari, let's say, is this point here. So, hahanapin natin ng f of x given yung f of x not. And we can approximate this by using f of x not plus yung dy natin, which is itong differential. So, yan yung parang increment niya para mahanap natin itong f of x. And take note that this is an approximate, ha? Hindi natin nahahanapin yung exact value niya. So, sa nag-question, okay ba? So, ayan, okay. So, next naman, okay, for this one, saan po galing ang 7? So, ang 7 natin actually, in-assume lang dito sa problem na yan yung starting point. So, take note na sa problem na to, we see na this is 7.02. So, iniisip lang niya na, kasi we're setting up kasi yung local linear approximation na formula eh. So, this is 7, tapos papunta tayo sa 7.02. So, bale, hahanapin natin yung approximate value ng f of 7.02 gamit yung f of 7 times ay plus yung ating slope times yung dx natin, which is yung difference lang no, from 7 to 7.02. So, gets ba? Sa nagtanong? Kung wala nang tanong, I'll answer this question. Hello po, paano po malalaman anong value ng x not gagamitin? Okay, for this, actually, yung typical na tip ko dito is kung ano yung pinakamalapit at pinakamadaling i-solve na value. So, kaya pinili ang 7 dito sa problem na to kasi if you substitute f of 7 dito, mangyayari is that magiging whole number to. So, since 7 plus 1 is 8, tapos cube root lang yun is 2. So, 7 times 2 is 14. Kaya yan yung pinili na x naught since yun yung parang madaling gamitin. Pwede mo namang i-try other values. Let's say gusto mong gamitin x naught equals 6. Pero ang point lang dito is that we're approximating naman yung value at a certain point. So, ayun. Nasagot ba ang tanong kung sino nagtanong nito? Okay, so kung wala nang tanong, let me proceed ngayon with problem number 5. Okay, let me full screen lang itong slideshow. Okay. So problem number 5. Suppose a cubic tank of side 3 meters to be coated on all sides in a special coating with thickness of 0.005 meters to protect it from leakage. Use differentials to estimate the needed volume of the special coating. So, like kanina, na-discuss natin differentials sa previous problem. Itong dy, which is approximately equal to dito. And now we're gonna apply this dito sa problem na to. So, how do we solve this? So, take note na ang formula ng ating volume is given by v of x equals x cubed. Take note one tip na binigay ko din dati nung previous MBAN is that you need to underline yung given problem. So, cubic tank yan. So, ibig sabihin, volume niya is of course x cubed kasi puro squares naman yung mga nandito with side x. So, x, x, x yan. So now, with that, we use this and we get that yung ating dV is equal to 3x squared dx. So then the volume of the coating material is given by, dV natin is approximately equal to ang ating delta V, which is equal to V times 0.05 minus V of 3. So ang dV natin is actually itong 3x squared dx. Then, difference naman natin is, yung dx natin is 0.05. So, imagine, i-2D ko to. So, kunwari meron kang coating dito, ay meron kang cube dito. So, bale, meron tayong certain differentiable and ang ating coating natin is represented by dx. So, yan yung gagamitin nating dx, 0.05. Tapos, ang initial natin is 5. So, yan yung substitute natin dito. So, this is equal to 3 times 5 squared times itong 0.05. Kaya, ang sagot natin dito ay 0.375 meter cube. So, meron bang questions for this part? Okay. So, saan po nakuha ang 5? Okay. Okay. So, saan nakuha ang 5? Wait lang ha. Ay, actually may typo pala sa problem. My bad. So, actually, yung mangyayari is that, ano pala to? May mali. So, at v of x is x cubed. So, ang ano pala natin, ang given natin is 3. So, dapat pala to, ano to, yung given natin should be 5, not 3. Yes, oo. So yung 0.375 po na nahanap natin, yung coating ng tank na may 0.005 meter thickness. Yes, yan yung volume ng thickness ng tank na yun. So if you try to solve it using non-algebraic method, I think you will get the same answer na 0.375. Pero ano to take note na approximate to. So it may not have the exact same answer. Ayun lang naman. Okay, so may tanong pa ba ang audience? So yeah, sa isang nagsabi ba't hindi po 3, dapat nga, actually dapat ano to, 5 yung given, hindi 3. Okay, so kung wala nang tanong, let's proceed with the last problem of the day. So as usual, I'll just share the slideshow. Okay. Now, we now proceed with 2 problems. So puro mga ano to, puro L'Hopital's na to actually. So we get to the exciting part ng ating lecture kasi now we can use L'Hopital's to find the limits ng mga functions na to. So evaluate the following limits. So we have the limit as x approaches 1/2 from the left of 3/2 minus x raised to second of pi x. Thus meron din limit, as x approaches in positive infinity ng 3 raised to x plus 3x all over pi raised to x plus pi x plus pi. So how do we solve this? Magre-recall muna tayo ng L'Hopital's. So L'Hopital's rule, so bale, usually this is applied to 0, 0 and infinity over infinity na indeterminate time. So let f of g be functions of an open interval I containing a except possible at a, and g prime of x is not equal to 0 for all x in IA. If yung limit nila is an indeterminate type form of 0, 0 or infinity over infinity, then kukunin lang natin yung derivative ng f of x at saka g of x, and we evaluate the limit at x approaches a nito. Provided na nag-exist siya or infinite limits siya. Remark lang natin na ang L'Hopital's rule with suitable modifications is valid for if f approaches a will be replaced by x sa mga one-sided limits at saka yung positive at saka negative infinity. So meron tayong ibang cases ng indeterminate forms. So ang una ay ang 0 times infinity. So kung ganyan yung form, tapos yan yung limit niya, so we try to transform the function into the following. So either yung gagawin nating reciprocal, yung g of x, or gagawin nating reciprocal, yung f of x. Tapos apply lang natin ang L'Hopital's rule. Next naman, kung infinity minus infinity yan, then yan yung kalalabasan. Combine mo yung f of x at saka g of x, tapos check if nagiging 0 over 0 or infinity over infinity, then we try to apply L'Hopital's rule. Then factor out the expression, and if the result is an indeterminate type of the form 0 times infinity, gawin lang din yung same method kanina. Then last but not the least, meron tayong 1 raised to infinity, 0 raised to 0, and infinity raised to 0. So we usually write this as a function of e raised to ln of itong f of x raised to g of x. Kaya, kalalabasan na distribute lang natin yung g of x sa labas. Kaya, e raised to g of x ln f of x, which is just, then we just find the limit nitong buong function na to. Then we solve for this. Tapos kung may 3 conditions tayo, kung may certain limit siya, then yung limit nito is equal to e raised to l. Pero kung infinity to, yung limit niya, magiging infinity. Tapos kung negative infinity, magiging 0. So bakit ganito? Kasi take note na we can dito sa 0, if ano yan, e raised to x yan, so kung negative infinity, ibig sabihin, nag-approach siya from negative values. Kaya e raised to negative x, tapos magiging 1 over e raised to x. So magiging 1 over infinity siya, kaya magiging 0 yung value niya. Then dito, ano lang yan, positive lang yan. So e raised to x. So pag approaching infinity, so ano lang yan, mag-i-increase infinitely. So magiging infinity yung value. So with that, let's solve the problems. So limit, so yung una, so limit as x approaches 1/2 from the left of 3/2 minus x raised to second pi x. So this is in the form 1 raised to infinity kasi as you approach from the left yung 1/2, yung form nito is pa-approach na to sa positive infinity. Then ito namang nasa loob, magiging 3/2 minus 1/2 which is 2 over 2 equals 1. So ngayon, because of that, we write this as a given function, itong as e raised to second pi x, natural logarithm ng 3/2 minus x. Then we'll just evaluate ngayon itong limit dito. So notice that the limit is an indeterminate form na type na 0 times infinity. Kaya ita-transform ulit natin siya into reciprocal. So kinuha dito yung reciprocal ng secant pi x which is 1 over secant pi x. So ito, then since ano naman yan, 0 over 0 na yan, we don't need to worry. So we now apply L'Hopital's rule dito. So ito, bale ang ln 3/2 minus x, yung derivative nito is 1 over 3/2 minus x times negative. Kasi derivative ng ito is negative x. Kaya may minus siya dyan. Then ito naman, cos pi x, derivative niya is negative sin pi x. Tapos derivative ng pi x is pi, kaya negative pi sin pi x. So take note na kapag sinatutute na natin ngayon ang 1/2, so yung taas, numerator, 3/2 minus 1/2, magiging negative 1. Tapos pag sinatutute natin dito ang 1/2, negative pi siya, negative pi times 1. So makakancel ang negative natin, kaya ang limit natin is itong 1 over pi. Kaya ang limit nito is in the form e raised to L. And since L naman tong 1 over pi, yung sagot natin dito is e raised to 1 over pi. So last, ito namang limit itong as x approaches infinity. So take note na pag sinabstitute natin ang infinity, t raised to infinity is just infinity plus infinity which is infinity. Tapos same consequently dito din sa baba, infinity lang yung sum yan. So we try to use L'Hopital's rule. So inunang L'Hopital's rule ito, kaya may yung derivative ng 3 raised to x is 3x raised to ln 3 ng 3. Tapos pi x ln pi plus pi x ay plus pi pala. So nawala na tong pi kasi constant naman yan. Tapos derivative ng 3x is 3. Tapos notice na ganun pa rin, infinity over infinity, maglo-L'Hopital's ulit tayo. Kaya 3 raised to x ln squared of 3 kasi may 3 raised to x ln 3 times ln 3 ka. Tapos constant to, mawawala na siya. Then itong pi x squared ay pi x, ano siya? Pi x ln pi. Pag multiply mo dito, magiging ln squared pi. Tapos mawawala na rin tong pi kasi constant lang siya. So, since ano to, yung ln squared 3 all over ln squared pi is a constant, pwede na natin tong ilabas. Kaya nasa labas to. So we now find the limit as x approaches infinity ng 3 raised to x over pi raised to x, and by exponent rules, pwede natin silang i-combine into 3 over pi raised to x. And take note na ang ating pi, wait lang, sorry, draw ko lang siya. We note na pi, which is just 3.14, etc., is greater than 3, which implies na 3 over pi is less than 1. So take note na important to, itong part na to, kasi hindi natin masasabi na 0 yung limit na tong as x approaches infinity. So we need to show an explanation na itong pi over 3, pi is greater than 3, implying na this fraction is less than 1, which is also less than 0, syempre, since positive value naman siya. So ayun, kaya ang limit natin, 0, tapos pag minultiply natin dito, ang final answer natin, itong 0 na to. With that, may question ba sa part na to? I'll double check. Okay. So, hello po. This is for previous question. May bibigay po ba kayong kopya ng formulas for areas and volumes? Um, pag-uusapan muna namin yan. May questions ba for problem 6? Okay, yung ibang questions dito, I'll just answer it na lang right after. So kung wala na, I'll now proceed sa final. So dito ko na isasagot lahat ng mga other questions. So are there any other questions in general? I saw some previews. So yung unang question is actually, wait lang. So hello po, will a samplex be provided to us participants? Yes. Just like nung LE1, meron tayong samplex na ibibigay, and usually after some days pa to after ng day 2, which is expect nyo next week. Basta before December 17, meron na kayong samplex, pati yung answer key. Then, is the meeting being recorded po so we can rush the video afterwards? Yes, it is recorded. In fact, actually, naka-live siya ngayon sa YouTube. So, kung papansin nyo, try nyo i-search MBAN, tapos makikita nyo tong recording na to mamaya. Then, next questions. Can we get a copy of the corrected slides? Yes, we'll actually be giving the copy of the slides. We'll be giving the copy of the slides, kasama na rin yung samplex. Then yung PowerPoint, through email ba? Actually, hindi. Ipapost namin siya sa MBAN page. Expect nyo na siya in the next few days. Then, iba din po ba yung mga examples sa F2F po na review or same lang po kayo? With that, actually, most likely iba magiging examples ng F2F. And I think yung F2F hindi na namin covered. So I'll be entertaining questions until mga 5:58. So if may tanong pa kayo, please ask now. Paano po nagkaroon ng LN2 sa problem 6 sa pangalawa? LN squared. Okay. So bale, 'di ba, nakuha natin na yung derivative ng na tong 3 of x. Wait lang, sorry. Wala pa rin annotate ko. So ang nakuha natin derivative ng f of x, itong 3 raised to x is itong 3 raised to x ln 3. So bale, ang ginawa lang natin, kinuha lang ulit natin itong derivative ng 3 raised to x. Tapos, since constant yan, ln 3 times itong 3 raised to x ln 3. So, bale, ang nangyari is that itong ln 3 times ln 3 is itong ln squared 3. Kaya may squared dyan sa taas. Sa nagtanong, okay ba? Okay, good. So next naman, will we expect marginal problems in the LE2? Yeah, actually, expect nyo in general na lahat ng mga possible pwedeng lumabas. So para just to be sure, handa nyo na sarili nyo sa lahat ng mga ganyong problems. Okay, so may 1 minute pa tayo for question and answer portion. So habol na please kung may tanong pa kayo.
I may add something. Hello, rinig pa ba ako?
Yes. Okay. So with that, yeah, ayun. Sige. So bale, it's already 5:58. So with that, uh, thank you for joining day 1 and I'll end na yung live stream natin. So wait lang.